So, good morning, everybody. Welcome to the lecture of business intelligence. Today is December 5th. Today we will look at regression algorithms, So this regression task is aims to make predictions based on data. Okay, and we will look at three algorithms. The first one will be the linear regression. Second one will be the polynomial regression, and third one will be the logistic regression. Okay, so the hypothesis here is we have gathered data, okay, from a system, and we aim, or that's the hypothesis. So we have data at this level. I will give you the data later on. When you are managers, you will see that getting the data is itself difficult. So our goal is to predict the behavior of the data, of the system, based on the data. Okay, so let's start with our linear regression. This is the easiest type of regression. So imagine we have some data set. I'll paint just 2 dimensions for clarity, okay, but it can be any number of dimensions. So we have 2 coordinates, 2 dimensions, and we have some data. Each data point has a coordinate x1, epsilon1, okay, and so on. So basically what we want is to find the line, this is the linear regression, that has the minimum distance to the point. So if we draw a line in the space and we calculate the distances between all the points and this line, we would like to find the line that has the minimum distance. You know, a line has this formula. We aim to find the distance that has the line that has the minimum distance to all the points, okay? Because that line is the one that better predicts the behavior of the of the system. So we aim to find the line that has minimum distance to the points of the data set. Okay, good. Then we have all we have to know is, in order to perform this algorithm, is that the area of a square is a square, and that the area of a parallelogram sides AB is equals A times B. This, I understand you know, and that is no problem for you. That's basically what we need to know in this linear algorithm. Why? Because the well, we also need to know that the tangent of a line, or the slope of the line, alpha is is b divided by a. Okay, if this is alpha, that we also need to know. So steps, like any algorithm, we have step 1, 2, 3, 4. Okay, the first step is to gather the data. As I said, I will give you this step done in the exam, so you don't need to take care of it really. I like it pretty, so let's make it pretty. So I give you 4 points with their coordinates. For some reason it's not. Wait, I need to close the Notes app and reopen it again. I don't know why it was not working. My Apple Pencil is not working all of a sudden. So it works again. So 4, 8, 5, 6, 13, and 3, 3.5. Okay. So this, the gather data, is something that I give you, so you don't need to take care of it very much. So the second step is something more challenging, but not very much. You need to find the mean value of the variables, because the linear regression crosses the mean value. meaning that the mean fulfills the equation of the line. This is important. Okay, so first we find out what is the mean value. To calculate a mean value is a piece of cake. This is 1 divided by 4, 3 plus 4 plus 6 plus 3 equals 4. And 1 divided by n, one divided by 4, 6, 5, plus 8, 5, plus 13, plus 3, 5, equals 7.87. All right. So you guys cool so far? Yeah, so step 3 is the challenge, okay? Step 3 is the challenge here. I mean, it's not a really big challenge, but calculate the slope. So the coefficient B1. So make sure you look now and you understand graphically what I'm doing, okay? Because the formula is not very difficult if we understand what we're doing. Like with anything in math, if you can explain it with pictures, it's all of a sudden it's demystified. So imagine we have a point here, or I mean we have many, but we have one exemplary point there, and then we have also a line. This is the potential line that we are looking for. And this has the equation x equal, epsilon or y equal b0 plus b1x. This is then alpha, okay? And we know that the tangent of alpha equals b1, okay? So we know that this line goes through the mean values of y and x, okay? So the slope, now please stay with me, okay? So what is the area of this square? So the square formed by the point xy and xi and yi and the mean value. What is the area of this? So the area of this, the area, if this is the point x mean value and y mean value, and this is x sub I, y sub I, the area is A times B, right? So as we saw above, so but what is A? Is xi minus x. And what is B? Is yi minus y mean, right? So the area is here xi minus x, yi minus y. Are you cool with that? So what is the units of this? It's an area. Okay, so if we want to have a slope from this, we need to divide this by another area that is unitary. So now we take the square centering the midpoint. So this square has an area of what? This line is xi. This square has an area of what? xy minus x squared, right? So if we divide these two areas, what we have is something that is not dimensional, and it gives you the slope. So B1 equals, of course, we do it not only for one point, we do it for many points. Okay. So we not only do it for one point, that's why we add up to all the points. So this is the slope that we're looking for. Okay. Adding up. Yeah, sure. What is the side of? I mean, this is a square, so both sides are the same. Okay. What is this z? It equals xi minus x, right? And then square because it's a square. Are you cool? No problem. Interrupt me as many times as you want. Okay, bitte unterbreche. Okay, das ist jetzt eure Aufgabe, zu nerven, bis es verstanden wird. Okay? Überhaupt kein Thema. Beziehungsweise nicht nerven, es ist halt, es macht Spaß, wenn es ein Dialog ist. Vielleicht habe ich es nicht so gut erklärt. Okay, so, dann nehmen wir uns die Daten von oben und dann setzen wir sie um. 3 minus 4 mal 6,5 minus 7,87 plus 4 minus 4, 85 minus 7.87 plus 6 minus 4 times 13 minus 787 plus 3 minus 4, 35 minus 787 divided by divided by 3 minus 4 square plus 4 minus 4 square plus 6 minus 4 square plus 3 minus 4 square. Okay, so if you do that with your calculator, you get to 483. Okay, so at this point we know our equation looks something like this: b0 plus 4.83 x. But we know step 4 that the line goes through x, y mean value. So y mean value equals b0 plus 4.83 times x mean value, meaning that if you substitute the values there, you get b0 times plus 483 times 4, so you get b0, which is going to be minus 11.46. So your final equation looks like minus 11,46 plus 483x. Okay? Minus 11 is the point where the line crosses the y-axis when x equals 0, and 483 is the slope. So why is this all good, or something that we want? Because if we paint this line, it will be something like this. I'm gonna put it there. So it'll be something like, let's say this is minus 5, minus 10. This is 5, this is 10, 5 and 10. So the line is going to be going through the midpoint, so the mean value is somewhere here, 4 and 7 something, somewhere here. So this is the mean value, x squared, y squared. And the point where it's crossing the y-axis when equals 0 is there. So we have something like this. I mean, a line is defined by 2 points, so we've got it right there. And why is this useful? Because now, when I ask you if x equals 3.9, what is the predicted value of y? Well, then you go and say y for x equals 3.9 equals minus 11.46 plus 4.83 times 3.9 equal 7.39. Okay? So you go and you say, okay, well then when my value is 3.9, somewhere here, I get 3.9, I get a value of 7.39. Okay? Any questions? As with any of these examples or any exercise that we do in class, when I do it, it looks piece of cake. When you do it in the exam, you will get the feeling that it's not so easy. So please make sure that you exercise. Okay. And how do I exercise? I give myself new numbers. That's the easiest. Okay, so you give yourself new numbers and then you can exercise. So is everything okay? Yeah. Okay, so now we've got second thing, nonlinear or polynomial regression, nonlinear, also called nonlinear. So this is a little bit trickier, not a lot trickier, but we aim, so our goal is we aim to find out the relationship between a variable x and other variable y with help of a non-linear regression. And as always, it's best to give you an example. So step one is gather the data. As we have done before, I'll give you some data now. And why do we need a nonlinear regression? Because not always the relationship between the data is linear. Okay, sometimes it's something like a curve or something like that. So calendar week 1, calendar week 2, calendar week 3, calendar week 4, calendar week 5. And let's say 1, 2, 3, 4, 5, and then 2, 5, 5, 8, 11, 9, 21, 4, 31, 2. Okay. So our hypothesis, and this is something that we need to tell the system, hypothesis, the regression is of order 2. So let's say it's quadratic. We can choose it to be of order 3, of order 4 is just more complicated. So the equation for a quadratic curve, for a parabol, is like this. So, and we need to find the coefficients A, B, C to find out the curve. So if we put the point 1, which is 1, 2.5, into the equation above, I get y is 2.5 equals a times 1 square plus b times 1 plus c. This gives us the first equation. Second is 258. So if we put that in there, we get that plus b times 2 plus c. This gives us the second equation. We need 3 because we have 3 coefficients. This is 3, 11.9. So 11.9 equals a times 3 squared plus b times 3 plus c. This gives us the third equation. So to solve this is something that I'm not going to get a lot of time with, so you should be able to solve this. I subtract equation 2 minus 1 so that I get rid of one parameter. So this is 5.8 minus 2.5 equals 4a minus a plus 2b minus b plus c minus c. So meaning these equals 3a minus b. So 3.3 equals 3a plus b. So if I subtract 3 minus 2, this is equation number 4. If I subtract 3 minus 2, I get 11.9 minus 5.8 equals 9a minus 4a plus 3b minus 2b plus c minus c. This equals 5a plus b. So 6.1 equals 5a plus b. This is equation number 5. If I say now 5 minus 4, then I get 6.1 minus 3.3 equal 5a minus 3a plus b minus b equal 2a. So it turns out that 2.8 equals 2 times a. So a is 1.4. B then because of 5 equals minus 0.9, and c because of 1, if I a and b substitute a and b, c is 2. So our equation of our prediction, and we put that with y and hot, is 1.4x squared minus 0.9x plus 2. All right. We use that to calculate our error. But you could use that too, instead of using, we just need 3 points. You can use the other, any of the 3. Yeah. You can use any of the 3. I'm just taking the first 3, but you can use any of the 3. Let's calculate the error. X and y, the data that we already have for then the prediction, which is I squared equals 1.4 x squared minus 0.9 x plus 2. And then the error, which is going to be y with a hot minus y. Okay, so that's how we look at it. And let's see what things deliver. So calendar week 1, calendar week 2, calendar week 3, calendar week 4, calendar week 5. 1, 2, 3, 4, 5. And then I'm just copying the data from above. 2, 5, 5, 8. 11, 9. 21, 4. And 31, 2. So if I substitute the data, x and y, in this formula, okay, I'll just do the first one. Is 1.4, 1 squared minus 0.9, 1 plus 2. This delivers 2.5. If I substitute the data, 1.4 times 2 squared minus 0.9 times 2 plus 2, this goes and delivers 5.7. and so on. I do the same 11.9, 21.4, and 31.5. So the error is going to be here 0, minus 0.1, 0, 0, and 0.3, which is a fairly good approximation of the data. So, okay, so we have a solution that works fairly well, little error. Of course, we want to minimize the error. We could go on and try to figure out what is if it's not 1.4 but it's 1.398 or something like that. Okay, but this is enough for our purpose. So basically, what we have, if we paint our stuff, this is X, this is Y. So 1, 2, 3, 4, 5, and then 10, 20, 30. Okay, so the first one is 10, 20, 30, 2.5. First point is somewhere here. Second point is somewhere here. Third point is somewhere here. Fourth point is somewhere here, and third point is somewhere here. Okay, so this is clearly a parable that goes like cutting at 2. Okay, so this is the way our curve works. This is the curve that we're looking for, and this is just the equation. So now we can ask, what is the value of y in calendar week 7? Okay, so y with a hot in calendar week 7 equals 1.4 times 7 squared minus 0.97 plus 2 equals 64.3. Okay, so in calendar week 7 it goes all the way up to heaven. Okay, any questions? Everything cool, or can you say something? I don't feel lonely. So of course, in another week, let's say, then we can represent what is the value in calendar week 2.5. Okay, it's exactly the same. Just go calendar week 2.5. 1.4, 2.5 square minus 0.7 times 2.5 plus 2. Okay, so this would be something like here, right? If we do that, can somebody do it? I don't have my calculator. please. Somebody do it, please. What was that? 8.5? 8.5. Thank you. All right, so we get that there, okay? You see the point, I guess. All right. Any questions? So now we have looked at linear and polynomial regression. Basically, with the polynomial regression, you can regress anything you want. You just need to add up orders of magnitude. At some point, it gets bizarre with the computation, but anything can be, any function can be regressed like that. With a logistic regression, we do something qualitatively different, okay? LR is a type of regression used when the dependent value or variable y is binary, okay? So it cannot take any value. It can be only 0 or 1, 0 or 1, yes or no, pass, no pass, or fail, okay? So the logistic regression predicts the probability of the outcome based on one or more independent variables. In this case, we only use one, okay? Unlike linear or polynomial regression, we predict where we predict a continuous value. Logistic regression outputs probabilities. That are mapped to a binary decision using a threshold. For example, probability bigger than 0.5 means 1, okay? So let's see an example, and a professor, example, a professor wants to predict whether a student will pass y equals 1 or fail y equals 0. Okay, an exam based on the number of hours they study. That's X. Okay. So step 1 is gather the data. This is given in this case. So X hours and Y pass or fail. So the data is 1 hour studied is fail, 2 hours study is fail, 3 hours study is fail, 4 hours study is 1, 5 hours study is 1, 6 hours study is 1. Okay. So these are the data for 6 students, and with this data we're going to calculate our logistic regression. Okay. Good. So step 2, the model, LR model. LR uses the so-called logit function to model the relationship between X and Y. The logic function is logarithmus of p divided by 1 minus p equals a line. Okay. Where p is the probability of pass, so y1, b0 is the intercept, and b1 is the slope of X. Okay, so this is the logic function, something that you don't need to know, but you know now. Okay. If we do a little bit of reformulation, p divided by 1 minus p equals the exponential of b0 plus b1x. Okay. Then we go and we say p equals exponential of b0 plus b1x minus p times exponential of b0 plus b1x. This means that p multiplying 1 plus e b0 plus b1x equal e b0 plus b1x. And as a result, we get that p equals 1 divided by 1 plus exponential of minus b0 plus b1x. Okay. So now we solve for the coefficients. Step 3, solve. Okay. For simplicity, we will estimate the coefficients so when x equals 3, y equals 0. Okay. And when x equals 4, y equals 1. Okay. So because this is the point where it changes, we assume that when x equals 4, the probability is going to be 0.5. Which, if we put in the equation above, 0.5, 1 divided by 1 plus a minus b0. Okay. So and when x equals 6, we assume p equals 0.9. Sorry, minus b0. Let me, oh, wait. Let me use the other formula. I prefer to use that one. P divided by 1 minus p equals exponential I use the formula above, formula 1, So using 1 logarithmus of 0.5 divided by 1 minus 0.5 equals b0 plus b1 times 4. And logarithmus of 0.9 divided by 1 minus 0.9 equals b0 plus b1 times 6. So logarithmus of 1 equals 0 equals b0 plus b1 4, and logarithmus of 0.9 divided by 0.1 equals b0 plus b1 times 6. So logarithmus, this is 2 and this is 3. So 3 minus 2 equals logarithmus of 0.1 divided by 0.1 equals 2 times b1. So can somebody do this, please, for me? I do it at 1.1, and as a result, if we put that in 2, b0 is minus 4.4. So our equation is like 1 divided by 1 plus e equals minus 4.4 plus 1.1x. This is our logistic regression. So this curve looks like this. Yeah, I subtracted this to this. So this minus 0 is this. b0 minus b0 is 0. And then b1 times 6 minus b1 times 4 is 2 times b1. Yeah, no problem. And then so the equation looks like this when this is b, when let me plot it here, wait. I'm gonna plot it with some program. This probability goes like this. This makes sense what I'm doing. 1 divided by 1 plus 1 divided by no, I'm not writing, I'm thinking. I need a little bit of thinking now. 1 second. Exponential minus 4.4 doesn't make sense. Yeah, so it works a little bit like this. This goes like 1 so for above 5 and around let's say 2 is 0.5, so it goes like this. Make it another color. This curve looks like this. Okay, so approximately. And so if I ask you what is the probability of a student passing the exam after studying 3.8 hours, then you put there in the formula 1 plus exponential of minus 4.4 times 3 plus 1.11 times 3.8. Okay, can somebody do that number? Should be somewhere between 0.5 and 1. Can you do it, please? No, that. Yeah, that might be correct. Yeah, that is correct. 0.44. Yeah, so I need to change this a little bit. So here our a little bit tricky with the logistic. function, but so this is the way it works. Okay, so here the tricky part is here. Okay, yeah, that's okay. It's basically a rounding issue. So this is the tricky part. Okay, so when you do this exercise, look for the values of x in which y changes from 0 to 1. Okay, and then assume that for 4 you have something like 0.5, and then for 6 you have, because it's changing from 3 to 4, is from 0 to 1, and then for 6 you have a 0.9. Okay, and then the rest is just implementing the equations. Yeah, well, and then solving this is just subtracting, as we already discussed. Okay, so we have learned linear, polynomial, and logistic regression, which is the basics of regression machine learning. Based on this, you can develop a lot of things. This is also used for deep learning. Probably you remember the ReLU function has a lot to do with the logistic function. I mean, it's all interconnected, but you'll start seeing that if you dive a little bit deeper on this. Anyway, any questions? Yeah, it's exactly. So you could take the 5. I mean, you need to know, I guess I didn't say it, probably my mistake, but you need to know that this function that I just painted here, let us paint the function, which is maybe from a didactic perspective much better. Let us paint this little function here, 1, okay? We'll paint it, and then I guess then you will understand. So when you do the let's say if you have a value of p that is 1, okay, this is p, this is x. If you have a value of p that is 1, then you divide, this part is 1 divided by 0, right? So x is going to be infinite. Right? Because the logarithms of 1 divided by 0 is infinite. Is that okay? If you have a value of p that is, let's say, 0, the logarithms of 0 divided by 1 is the logarithms of 0, which is what? What is the logarithms of 0? Or very close to 0? No, not okay. What is the value of a number that is very close to 0? Positive, but very close to 0. Tell me. So it's 0.0000000000000 something, right? So because b to the pointed of 0 is x, okay? So it's it goes. Wait, I'm getting a call here. It's going to be something like it's minus infinite. Okay. So it's going to be like going that way in the x. So if you have those two behaviors asymptotically, and I painted you that little S curve before, what we can say somehow is that our sigmoid function is going to be something like this. Okay? So what we're looking for here is the transition. Here we don't know what is going, where is this transition going to be? At what x is the transition going to be in our data, right? So you look for the value of the transition. Yeah, 3 and 4. And then you take the 4. You say, okay, in this transition, I'm in the middle. So because I'm in the middle, I'm going to be here 0.5. Okay? And then you take the last one and you say, okay, this is going to be very close to 1. Okay? Okay, so this is going to be very close to 1. You can say 0.99. It doesn't matter, okay? The logic is going to be the same. Yeah, that's what we're looking at. Yeah, no problem. Any more questions, please? Any more questions? Actually, this curve, let me paint it again. It's not totally correct because it ought to be positive. So it should be like this. Okay. So around here is 0.5. Here it's 1 and here it's going to be 0. But the logic is valid still. So any more questions? Well, you don't figure it out. You have it in the data. Here between 3 and 4. Yeah, you need to figure out the coefficients of this B0 and B1. And for that you take first the point where it starts to be 1, x4. You call it probability of 0.5. And then you take the highest value and then you say the probability is close to 1. Okay, and then you solve. So let me write it. First, we take the point x equals 4 where transition starts. Second, we take the point x6 where transition ends. Okay, and then here you say P05, and here you say P01, P09, okay? Or 99. Okay? Du kannst in Deutsch fragen. Ja, hier. Deshalb diese 1 in Klammer, hier. Der 1 in Klammer. Du kannst es mit der anderen Formel machen, aber so ist es einfacher. Ja? Okay. Weitere Fragen? More questions? All right.